Good. Okay, so here's what we're going to do today, you guys. We'll review just a problem from Wednesday's lesson real quick. And then we have another lab today. This one's called the Rocket Sledder Lab. I think you'll like it. And you should be able to easily get it finished before the end of the class today. Okay, so here's the problems from Wednesday. So just to review what we were doing again, we were solving all of them for acceleration, but only knowing the force and the mass. So this problem here, we have a student on a skateboard. It has a mass of 85 kilograms, V naught of 2.5 meters per second, and is accelerated by a force of 650 newtons. So if we do force divided by mass, it would be 650 divided by the 85 kilograms. And that gives us an acceleration of 7.6. And what I did and that's meters per second squared, when we grade these, I usually just look at one or two of your answers, scrolling through them real quick. And if you have the one or two that we see, you usually get full points. If you don't, then I'll check some other things. But some of you guys, again, and I don't know why this is happening, especially when you have two teachers to help you. Some of you are not doing anything else than what we go through when we do this. So if you have questions, I had a few kids last hour jump back into the Google Meet. Even if you leave to work on your own, you can always come back and ask questions, and we'll walk you through stuff. Now, some of you guys were asking questions too, which is a good job. Okay, so now what we want to do is find the final velocity after 2.5 seconds of time. And this is our A. Our acceleration is 7.6. So we want to find something that starts with V, a formula that starts with V, and includes A, T, and V naught. And includes A, T, and V naught. And that would be this one right here. Starts for final velocity, includes A, T, and V naught. Do the old copperoo. And then there's our formula. So we're going to multiply A times T, 7.6 times 2.5, and then add V naught to it. So plus 2.5, and it gives us an answer of 21.5, and that's meters per second for velocity. Why are my cap locks on? Okay, so again, just a sample or going over one of the problems from Wednesday. And from looking at what you guys turned in of all of my physics classes, you guys did do a good job on this. Sometimes I focus too much on what the kids aren't doing, and it frustrates me. But I think from looking at the big picture, 80% or more of us did complete this and did it accurately. So that's good. Anything to add to that, Ms. Molesky?
No. Well, yes, I did send an email out to a lot of students yesterday. So please check your email because I gave you some tricks and tips in there for getting credit for your assignments. So if you got one from me, please read it.
And I did see that. That was good. Okay, so this is what you guys are going to do today. If you go into Google Classroom, and again, underneath the assignments to turn in, there's the Rocket Sledder Lab. So let me just show you this stuff real quick before you start playing around with it. This first section right here, if you click on this, it'll bring you to the actual lab. So I'll show you parts of the Google Doc you can skip, because the entire first section of the Google Doc is helping you get here. But if you just click on this, it'll bring you to the Rocket Sled Lab. So this is the Rocket Sled Lab, and let me just show you some of the basics of it. You'll need a stopwatch. If you don't have your phone or a stopwatch, you can use a clock at home. or you could even just count on your hand if you wanted to. Because really the main part of the lab is you getting the time it takes to go from 0 to 50 meters per second. Or there's a part in the Google Doc that actually tells you and walks you through how to open up a split screen so you can open up a stopwatch on your Chromebook. Okay, so listen, let me share this real quick because this is what you're going to do. You're going to take the sled from an initial velocity of 0 to a final velocity of 50 by changing the applied force. And I'll do a trial for you. And then you're going to type the time in, and once you know the time, you're going to solve for the acceleration.
Can you show them the applied force column so they see what numbers?
Show them what?
Just put your arrow over where it says 50, 100, 150.
Oh, okay. So this is the applied force column right here. This is what you're changing on the rocket sled. So let me show you the 50 real quick, and I'll time it for you. So I'm going back to the old rocket sled. Now watch this. Watch this. This is how you change the force. And I'm just going to show you a few things before I time it. So if I want to go to 50 newtons, that's right there. I'm going to bring it back. When you want to stop it, you turn on the air drag and the friction. That'll give you a parachute, and it will shoot some snow up when you're going really fast. So now let me time this. I'm going to use my phone. So the stopwatch on my phone, and I'm going to set it to 50 newtons and start the stopwatch. There she goes. You can see the rocket shooting out the back of the sled. And I'm going to time it until he reaches or she reaches a velocity of 50 meters per second. The speedometer right here will turn red when he reaches 50. So watch this. And almost. And stop it. Okay, so now I'm just going to slow him down. Turn on the parachute. You can see the snow shooting out. And that'll bring him to a stop for your next trial. So now I'm going to go back to this right here. That was 50 newtons of force. And on my clock, it took 36.6 seconds to get there. So I type that in for time. And then I can find acceleration, v minus v naught, or 50 minus 0, divided by the time that it took. So all of these actually will be 50 divided by the time that it took. So I'm going to do 50 divided by 36.6. And it equals 1.36 meters per second squared. You will do that, but you will change the force each time. And then the only question that kids had from third hour, a couple kids came back and asked, is how does an increase in the applied force affect acceleration? You'll just talk about the time that it took to get to 50 when you increase the force. Or you can talk about this number also, but what happens to the acceleration when you increase the force. So that's number 6. Okay,
you guys think about it. If you're pushing somebody on a sled, you should be able to even predict now what would happen.
Okay, so listen, I turned off the recording.
She wanted to know, how'd you get the 2 meters? Wait. What do you, Claire, how did you get, or the question is, how do you get